All right, let's get started. Welcome to the live, guys. Sorry if I'm a few minutes late. So today we're going to do some papers I've done. Awesome. So today we're going to go through the 2020 and 2021 mechanics papers, and these are the October papers. I did the stats papers yesterday, the counterparts, and I've uploaded the live to my YouTube. It's got the same handle if you want to check that out later as well. So we're going to do 2020 paper first, the full paper, then 2021. So I'm going to jump right into it. Look at the first question. All right. So a rough plane, I'm just going to change the color. Give me 1 second. A rough plane is inclined to the horizontal at an angle alpha, where tan alpha is 3/4. So straight away, I'm going to join my triangle and draw my triangle. That's alpha. The opposite and adjacents are 3 and 4. So this is just a 3, 4, 5 triangle. Then straight away write down what sine and cos alpha are. So sine alpha is 3/5 and cos alpha is 4/5. Write them down straight away so you have them to refer to. A brick P of mass M is placed on the plane. The coefficient of friction is mu, that's helpful. Brick P is in equilibrium and on the point of sliding down the plane, and is modeled as a particle. Using the model, part A, find in terms of m and g the magnitude of the normal reaction of the plane on brick P. So the second last video I posted does this. So what I'm going to do is I'm going to draw the entire situation happening. So firstly, I know it's on a slope. So I'm going to draw my slope, and this angle here is just alpha. It's a rough slope, and I've got the brick placed there. What's its mass? Its mass is m. So the weight, which is the force of mass, is mg. Remember, when doing these, we have to resolve parallel and perpendicular to the slope. So perpendicular is mg cos alpha, because this is also alpha. And going down the slope, this is mg sine alpha. Now, I know that it is on the point of sliding down the plane, which means that, friction acts in the opposite direction to the motion. So friction will be acting this way, mu r. And you've got the maximum friction. And we've also got the normal reaction force over here, which is R. Part A wants us to find the normal reaction force. So if we just look at our diagram and see what are the forces perpendicular to this slope, well, it's just going to be mg cos alpha. So R is equal to mg cos alpha. We know what cos alpha is. If we look up here, is 4/5. So that's just simply 4/5 mg. And that's it for part A. So I'm just going to label my diagram there. So you can see I didn't need all this information, but drawing the diagram straight away helps you to understand what is happening in the question. Part B, show that mu is equal to 3/4. So which plane is mu acting in? Mu is part of the parallel on the slope. So to find mu, I'm going to resolve parallel to the plane, and I'm going to go downwards. I'm going to take down as my positive. So this force is going downwards. That's mg sine alpha. And what is my other parallel component? Just mu r. That's Fr max. So mu r. So mu is going to be equal to mg. What is sine alpha? I did it up here. Just 3/5 times 3/5 divided by, what is r? 4/5 mg. The mg's cancel, so that's just 3/5 divided by 4/5. So I get 3/4. So therefore, mu is equal to 3/4. And that's a really nice 4-marker right there for part B. Is this making sense so far? Awesome, you joined on time. Mechanics, I'm going to be completely honest with you. Mechanics, at the end of the day, this type of question is all about trig and resolving. Whenever you get this question, you see what I've done here? I've labeled all my forces and resolved parallel to the slope and perpendicular to the slope. Then you just see making equations either side on the left and right and top and bottom of your thing. Exactly, diagrams make it 100 times easier. And yeah, these are my favorite types of questions too. And I'm glad this is like a bigger question. All right, awesome. For parts C and D, you are not required to do any further calculations. So they don't want to see you do any more maths on this sheet. You can still do maths on your calculator, somewhere else. So brick P is now removed from the plane and a much heavier brick Q is placed on the plane. The coefficient of friction between Q and the plane is also 3/4. Okay, so that doesn't change. Explain briefly why brick Q will remain at rest on the plane. And it's one of those annoying one markers. So does anyone want to have a go in the chat and let me know why they think brick Q will also remain at rest? Or let me know if you don't know as well. That's also fine. Can you do a hinges question? This paper does not have a hinges question, unfortunately, but if we have time, either today or tomorrow, I'll try and do one, or I might upload a video for that. The force is less than friction. Nope. Remember, this brick is not moving, so they're still in equilibrium, right? So I'm going to write down, no worries. I'm going to just have to make a note of that somewhere. All right, so for part C, I'm going to write out the logicking for this so you can read along. So if the brick is heavier, what does this mean? The weight of the brick increases, but since the perpendicular weight from our diagram, the perpendicular weight is this bit here, mg cos alpha. Since that is equal to the normal contact force, which is R in this case, the normal contact force also increases. But since the normal contact force increases, F equals mu R, which has the normal contact force, so does the friction. So therefore, the friction will increase in the same proportion as the weight component down the plane. Does that logicking kind of make sense? It's a bit of a weird way around it. Increase of R, exactly. Increase of R is proportional to the brick's mass. The force and the friction is balanced as mass is gone up. Exactly. And I don't get it. So, though you kind of have to logic this through. This is one of the questions where it's just physics and mechanics, right? So, I'm placing a heavier brick. So, let's say that brick has a mass big M, okay? The mass down the perpendicular to the plane is going to be big mg cos alpha. That means the reaction force is also going to be 4/5 big mg. The friction, which is mu r, is going to be mu times 4/5 of big mg. Another way about doing this is, if you look over here at this line of working, the forces balance because the mg's cancel. You can see that m's cancel out here. So it doesn't really matter what m value you have, the forces are going to balance for this because of the way the question is set up, the numbers that are given. Does that make sense? You're also allowed to just say the forces are all balanced because the force up the slope is balanced with the force down the slope. Why? Because the m values cancel. So the mass of the brick doesn't actually make a difference here. All right, part D. Brick Q is now projected with a speed of 0.5 meters per second down the line of greatest slope of the plane. This phrasing here just means it's just the big long part of the slope. Brick Q is modeled as a particle. Using the model, describe the motion of brick Q, giving a reason for your answer. So remember, you don't want to do any calculations, but it does help to visualize this and draw a diagram. So I like to draw a diagram here, and I'm going to draw my little slope because remember, diagrams are going to be your savior in this exam in mechanics, okay? So it's going down the slope now with a speed of 0.5 meters per second. I've still got my little weight components there, and I've got a friction there, okay, and I've got a normal reaction. All right, cool. So these are all the forces that are acting on my brick, right? There's no other forces. It's just been pushed with that speed, but there's no constant force. It doesn't say a constant force acts on this down the slope, which causes this constant velocity. No, it just says it has been, what's the phrasing they've used? Projected. Projected means just set off, and now it's on this speed with no other forces. That's the main thing you need to get. So you can see here that there is no resultant force down the plane. Why? Because this force and this force are still balanced, right, from the previous parts of the question. And the velocity is not a force. It does not have a force causing it. It has just been projected initially. Therefore, if you've got no force, you have no acceleration because F equals ma. Because F equals ma. So what is, now I need to answer the question. Describe the motion of brick Q. So I can say that Q slides down with a constant speed. They have not introduced any like constant acting forces. So you can see how I've logicked this through. I'm told that it goes at a speed of 0.5 meters per second down the slope. There are no extra forces, which means that the net force is still zero on this. So if I've not got any net force acting on it, remember, there's not going to be any acceleration. If there's no acceleration, you've got a constant speed. So that's what you say for this question. That's how you've logicked it through. So the reasons you'd have to say are this is your reasoning, and this is your motion for 2 marks. Does that explanation make sense, everyone? How we've worked that through? The question asked, describe the motion of brick Q, give a reason for your answer. Is projected down. So I said that the motion is it slides down with a constant speed. That's its motion. What is my reasoning? Well, there's no resultant force because the forces are still the same as in the previous parts. So there's no acceleration. And if there's no acceleration, it's a constant speed. That's how you do this type of question. All right. How was question 1? Did question 1 make sense? I'm not going to lie, parts C and D are not types of questions I would love to have. I would just like to do a lot of maths with these questions. But if you logic it through and think about what is actually happening with this, imagine you are pushing that ball down the plane, okay? Just think in real life that what is happening with those forces too. I don't get C. All right, if you haven't started revising, it's not too late. You just have to keep revising consistently. I'm going to re-explain C again. So the coefficient of the coefficient between Q and the plane is also 3 over 4, so that hasn't changed. So why is Q also remaining at rest? If we look in this equation up here, you've got the mass of brick P as small m, right? In this calculation, to figure out what mu is, the masses cancel. They have no effect on the coefficient of friction. So that's one reason you can say that the brick remains in place. Alternatively, the brick is heavier, right? Which means that the weight increases. The perpendicular part of the weight, which is this bit over here, mg cos alpha, also increases. So the reaction force increases, right? Because this is still in equilibrium. The perpendicular forces have to balance. Otherwise, this thing would be like floating or sinking. So if the normal reaction force increases, what else increases? Friction. Why? Because friction is equal to mu times the normal reaction force. So if you put a heavier brick on that slope, the friction is also going to increase if the coefficient of friction stays the same. So if the friction increases in proportion to the weight, that's why it does not move down the slope. This one is a bit of a longer process of reasoning, but if you take it step by step, see what is increasing, see what equations does that relate to, and then just follow along that line of reasoning, and that's how you do that question. All right? So, oh yeah, chemistry. Chemistry is on Friday, I think, right? It's the last exam. Yeah, basically friction and weight is the same. No, so friction is mu r, remember? But the weight is mg. We're looking at this component of the weight, the perpendicular component of the weight to balance with the normal reaction force. This would be mg cos alpha, right? Because we've just resolved it with that alpha there. So that means that r is going to be mg cos alpha, which is that. This is having a big M, right? Friction is mu r, right? So you can see that friction would increase because r increases because the weight increases. That's how you could go. So yeah. All right. So that is question 1. Not a bad question. Part C and D though, like I don't really enjoy, but it is what it is. So question 2. These questions are some of the nicer questions on the paper, but we need to be careful with them. So when you see these type of questions, you need to think, are you going to use variable acceleration or constant acceleration? Can you guys let me know what do you think you do here? Is this a variable or constant acceleration type question? So I'm going to start reading this. What subject? This is mechanics, A-level maths. So, a particle P moves with acceleration 4I minus 5J meters per second squared exactly. It is constant. Nope, it is constant. Don't worry. The reason it's constant is because there is no T letter here. So that's my rule of thumb. If there is a T in the equation for acceleration, if T in acceleration equation, it is variable. Why? Because the acceleration will depend on the time. Here, the acceleration is just 4I minus 5J. There's no time component or distance component there. So that's why you know it's constant. At t equals 0, p is moving with a velocity of negative 2I plus 2j meters per second. Find the velocity of p at time t equals 2 seconds. So this is a constant acceleration question, which means if it's constant acceleration, there are two ways to do this. You could either do suvat, or you could integrate or differentiate. Okay? If you had a variable acceleration question, you cannot use suvat because a is changing. You have to use integration or differentiation, calculus. So they want me to find the velocity at a certain time. How am I going to find the velocity at a certain time in this question? Does anyone want to let me know how you do that? The right suvat is offensive. The right suvat equation is offensive? What does that mean? So I know that acceleration is equal to the rate of change of velocity, dv by dt. So I want to find the velocity at time equals 2 seconds. I wrote it and deleted it. All right. So a equals dv by dt. What do I want to find? I want to find the velocity. So how am I going to get the velocity? Well, I'm just going backwards. So if I'm going from acceleration to differentiation here, I'm going to integrate going the other way. It is the integral of acceleration with respect to time. It's kind of like when you're doing, now that you've done year 2 integration, this is just separating the variables technique. You multiply by dt there and you integrate both sides. So this is how you would do that. This does not mean it's variable acceleration. You're just allowed to use this method as well to jump between them. All right. So if I've got a integral, I'm just integrating 4I minus 5j with respect to time. So if I increase the velocity, if I increase the powers of t by 1 divided by the new power, I just get 4ti minus 5tj plus c. And you're going to see why. Now you're seeing t's here, right? But you're going to see why it is not variable when we find what our constant is. So at t equals 0, I need my boundary condition, which they've given me here. The velocity is equal to minus 2i plus 2j. That is going to be equal to c, right? Because t is 0 gets rid of these t components. So at t equals 2, you have the velocity is equal to 4t minus 2. Those are my I components, and I'm just switching to column vector form 2. And then you have minus 5t plus 2 for my j components. If I multiply in t as 2 there, I get 8 minus 2 and negative 10 plus 2, and I get 6 minus 8. And I like to answer in the form of the question, so here they've given it in ij notation, so I could then just say that v is equal to 6i minus 8j meters per second. So this is one method, the calculus method. Let me just check any questions. You could do it as v equals initial. Exactly, that's the other method we can do, the suvat method. In my opinion, doing the suvat method is so much easier if there's constant acceleration, and you're going to see why. So the alternative method, v equals u plus at. What is my initial velocity here? Minus 2 and 2, right? Because that's the velocity at t equals 0. plus acceleration is 2, the time is 2, and acceleration is 4 minus 5. If I just multiply through and add my normal vectors, I get this. And what do you know? You have 6, negative 8. This is much faster. This is what I recommend you to do in these type of questions. This is the 2020 paper for mechanics. Where did I get minus 5 plus 2t from? Here, the minus 5 plus 2t are my j components. So here, I've got minus 5t plus 2, because c is my constant there, right? So if I just put c where that is where I get that. Why are you adding the two velocities? I have not added the two velocities. What I have done is I have added the velocity to its constant when you've integrated, right? How do you know if it's variable or constant? At the top, if you have a t in the equation for acceleration, it is going to be variable. If there's no t in that equation, it's going to be constant, because the t shows that the acceleration is changing with the time. Here, this is just the acceleration the entire time, which is why you can use this method. I 100% recommend using this method if it's constant acceleration. Do not put in all this work. It's just unnecessary. Awesome. And thank you everyone for helping each other out in the chat. It's really good to see. So, next part of the question. At time t equals 0, p passes through the origin. At time t equals t seconds, where t is greater than 0, the particle passes through point A. The position vector of A is lambda I minus 4j relative to O, where lambda is a constant. Find the value of t. So, here, what information have I been given? I have been given a position vector, which is r. So I'm just going to write that down because all those words are kind of confusing. So if you just put r is equal to lambda negative 4.5, and that's its position vector, right? So how am I going to do this? Remember, this is a SUVAD type question, so we can just use constant acceleration formulas. So if I've been given my initial position, and we know that at time t equals 0, it passes through the origin, well, that's just r naught. So we don't need that offset. I have my initial velocity, I have my acceleration. I just need to find the time, right, where it is in that position. So writing down my values, s is given, or r. U is equal to negative 2 meters per second. V we don't have, but we don't need. Acceleration is 4 negative 5 meters per second squared, and the time is t. The equation that links these is r equals ut plus half at squared. Subbing in, we have lambda minus 4.5 equals minus 2t plus half at squared is plus 2t squared minus 2.5t squared. Does this make sense so far? All right, awesome. So I'm going to have to solve for lambda, right? What is the question asking me for? Find the value of t. Okay, first I need to find the value of t. Using this, what can I do to find the value of t? Does anyone want to let me know? Or I'll just say, how do you know that c is equal to that velocity? Sorry, which bit? C. Oh, in this one, c is equal to that velocity because at time t equals 0, that's the only time they've given me up here with a condition. So if I sub in 0 and 0 here, well, I get the velocity is just that, which is just c. Quadratic, exactly. I'm going to solve this quadratic over here to find what t is. So if I just solve this out, I get negative 2.5 t squared plus 2t plus 4.5 equals 0. I just brought this on the right side. If you put that into your calculator, you get 1.8 and negative 1. Obviously, time cannot be negative, so this is your answer. Then you can then just say t is 1.8 and do your little scribble underneath. So that is how you find t. Also remember, if there's an exactly, you need to remember to add RO. So R naught, if there is an offset. So here, at time t equals 0, its initial position is 0, 0 through the origin, which is why you don't need to add that offset. Could you do any one? So the reason you could not do this quadratic to find t is because you don't know what lambda is. But funnily enough, that is the third part of the question. Hence, find the value of lambda. So now for part C, look at the I components. So lambda is equal to -2 times 1.8, that's minus 3.6, plus 2 times 1.8 squared, because we know that t is going to be equal to 1.8. That's what we found. It cannot be equal to -1. So then lambda is just equal to 2.88 or 72 over 25. You can give both answers, and that is how you do this type of question. Yo, wallahi, this is cooked. Don't worry, like you've still got 2 days. Just lock in for the last few days and you'll be fine. All right. So, does this question make sense? You can do either method, but I 100% recommend if there's no variable acceleration, use the SUVAD method. This is much faster. Then just logic it through. Can you quickly explain part C and D, B and C? All right, cool. I will. So they're telling me that at t equals 0 is passing through the origin, right? That's R naught. At time t equals t, it passes through point A, and A has this position vector. They haven't told me what lambda is, but I know what J position is. Find the value of t. So I've been given some values, and with this, I'm always going to be doing SUVAT. That's the only thing I can really do, right? So I know my S or my R value is this that they've given me at A. My initial velocity is this, which was in the question. Acceleration is that, and the time is at t seconds. The equation that links these is r equals ut plus half at squared. Remember to add the r naught if there is an offset. Here, r naught is 0, so I don't really need to add anything there. So then I just put my column vectors into the equation, and I get this. And they wanted me to solve for t in part B, right? Using this, there's only one way I can solve for t, and that's by looking at my j components down here. So if I equate that all to 0 and solve this quadratic, I get two values. T is not equal to -1 because time cannot be negative, so this is my value of t. For part C, they want us to find lambda. They're saying hence find lambda, so we need to use part B to find part C. Well, the equation with lambda is up here, and we know what t is now, 1.8. So lambda is equal to -3.6 plus 2 times 1.8 squared, and you get lambda as those values there. So that's how you do part B and C. No worries, I'm glad it helped. What topics would you recommend? So I recommend focusing on, for stats, normal distribution, binomial distributions, hypothesis testing. Those come up all the time. Linear regressions and PMCC tests. You can check out my YouTube for the live from yesterday. We did a bunch of those. And probability distributions and like word problems, Venn diagrams and bus stops and all that. Maybe histograms if you struggle with that, because God knows what they could assess with that. And mechanics, projectiles, doing all those applications of forces problems, and of course doing variable acceleration with the integration and differentiation, and integrating and differentiating vectors and stuff like that. I'm going to try and upload this by tomorrow morning. I wanted to upload it soon, the one from yesterday soon, but it took 3 hours to upload onto YouTube. So I was just up till like late, and I was like, I'm going to leave this. It's going to be ready by 2 a.m. Yeah, just do the papers, mech. Exactly, good. Can you do variable? So you can do variable acceleration up here. I think there's a question later on. Right here. Awesome, guys. There's a variable acceleration question down here, which we're going to do next. Discrete probabilities is always hard for no reason. Exactly. The first video I posted today about the XP points and all, that does discrete random variables and kind of how to logic it through. Unfortunately, there's no way to, teach you a one-size-fits-all method for that. So you just have to like I said in the comment, take a breath, try and logic it through, understand what the question is asking you, and look for combinations and stuff. I despise statistics too. I love mechanics, which is why I'm enjoying this live much more. All right, so ready to do a variable acceleration type question now. So at time t seconds, where t is greater than or equal to 0, it's sometimes helpful to look at the boundary conditions. A particle p moves so that its acceleration is given by this. This is variable acceleration. In your exam, I recommend writing down what type of acceleration it is. Why is it variable? Look, you've got t there and a t there, which means that the acceleration changes as the time changes. At the instant when t equals 0, the velocity is 36i meters per second. Find the velocity of p when t equals 4. So I'm going to write in big up here. The acceleration is not constant. So you do not use SUVAT here. You have to use calculus, which is differentiation or integration. So how am I going to do part I, part A? I want to find the velocity, right? Well, velocity, you're just integrating acceleration like we did in question 2. So with respect to time. So what am I integrating here exactly? 1 minus 4ti plus 3 minus t squared j with respect to time. So whenever you're integrating a vector, just do each part separately. It's not much different to integrating a bunch of different terms in an integral. So you have t, increase the power by 1 and divide by new powers, minus, this would be t squared 2, and that's all I. And now I do my j1. So that's 3t, and then that would be t cubed minus 1/3, and that's j, and you have a constant. The thing you need to know about this constant is it's also going to be a vector. All right, so how am I going to find the constant? Well, I need to see any conditions they've given me here. At time t equals 0, v is that. So at t equals 0, the velocity is going to be equal to, so this is all going to be equal to 0, and this is all going to be equal to 0. The velocity is going to be equal to c, which is going to be equal to 36i. So this is my constant. So therefore, the velocity, and I'm going to write this as a column vector now, so my i's are on top, j's are on bottom, will be t squared minus 2t squared, sorry, there's no squared there, minus 2t squared plus 36, 3t minus 1/3 t cubed, and there's no j component for my constant, so there is my velocity. Have I answered the question? I have not. I need to find it when t equals 4, so I'm just going to sub in now. At t equals 4, v is going to be equal to 4 minus 2 times 4 squared plus 36, and 3 times 4 minus 1/3 of 4 cubed, and that is going to be equal to 8 and negative 28 over 3. And like I said, I like to give it in the way they've set it out in the question. So here's an I and J notation. So that's 8i minus 28 over 3j meters per second. And that's how you do part A. Does that make sense, everyone? Excel's moving mad. How did you get 36? 36 is given by my boundary condition, right? So I've integrated an indefinite integral, so I have a plus c. How am I going to find this plus c? I need to look. Have they given me a t value and a v value? They have t and v there. So at t equals 0, v is going to be equal to, sub in 0 here, all of these get deleted, and you just have the c. Well, what is the velocity at t equals 0? 36, which is where you get the 36 from. Oh, never mind. Okay. Where's the integrate? There is integration on paper 3, Ronnie. So yeah, integration and differentiation. Don't worry, it is not so bad. If you know how to differentiate and integrate, just know how to get from displacement to velocity to acceleration, you're differentiating. And if you're going from acceleration to velocity to integration, to displacement, you're integrating. It's just like that. And that's like physics. I will be posting this on YouTube as soon as I can. If you don't see it by around midnight or 1 a.m., it's going to be posted tomorrow morning as soon as I get up. I'll probably let it upload overnight. How do you know when you need to do this though? So the way you know you need to do this is you look at the equation they've given you. This is variable acceleration. Why? Because there is a t value in this equation. So that acceleration depends on the time, hence it varies. If you've got this, acceleration is not constant. I've said you are not going to use SUVAT, you have to use calculus. And if you know the definitions for them, you know that velocity is rate and change in displacement, right? So velocity is equal to ds by dt. Acceleration is rate in change in velocity. So you can see you're going this way, you're differentiating. To go backwards, you just integrate. So if you want to go from acceleration to velocity, integrate. This is how I like to remember it. Awesome, now I get how this is variable acceleration. I'm so glad. When I ask for another form, there's a special velocity. Yep. Awesome. I'm glad this is making sense for everyone. Keep the questions coming and keep helping each other out in the chat. This is not GCSE mini. Do not worry. This is A-level stuff. GCSE is done. I had a bunch of people in my live yesterday telling me, why are you still doing maths? GCSE is over. I was like, A-level students are still suffering. Okay, part B. Find the value of t at the instant when p is moving in a direction perpendicular to I. So this is about velocity, right? So for B, do I have enough space to do it here? Yeah, no, yeah, I do. So B, if moving perpendicular to I, well, I'm just going to draw out that arrow, right? So I is this direction here, right? It is horizontal. So if it's perpendicular, it will be going this way. So the I component is equal to 0 clearly, right? Because there's no horizontal movement here. So that means I can just say that, well, where's my I component for my movement? That t squared minus 2t squared. Why do I keep saying t squared? Apologies. T minus 2t squared plus 36. That's going to be equal to 0, right? Why? There's no I component. So t, if I just solve this quadratic, I get 4.5 and negative 4. Shocker, I've got a negative value which I'm going to disregard. So therefore, t is just going to be equal to 4.5. And that's how you do part B. That's a much nicer 3 marks, but you have to make sure you know what the question is asking you. So just think about it logically. If you've got it moving perpendicular to I, you have not got any movement in the I direction. There's no movement this way. It's just going up. So if there's no movement across, you know that the I velocity is going to be equal to 0, which is that thing. Set equal to 0, solve for t. And that's all you have to do. How'd you get 2t squared from 4t if you're integrating? Over there. So you increase the power of t by 1, so it goes from t to the 1 to t squared, and you divide the coefficient by the new power, so it's negative 2. When do we set I equals j when it's parallel? You said I equals j when it's moving in this direction. Let me just draw it out. So if it's moving in a direction like this, you can see the I components are increasing as the j components increase. That's when you would set I to j. You could say it's moving northeast. That's like sometimes how the phrasing of the question will be. Yeah, increase power and divide. All right, what is ij? Would like this? Is that what you're asking? Question mark. Velocity, acceleration, differentiation to go up, and integration. Velocity, speed, velocity, acceleration. Differentiation to go down, and integration to go up. Exactly, that's what you have to do, Ronnie. Right. Thanks for helping Ronnie out, Rad. Yes, this, IJ, what is that? I don't think they can tell you like is moving in IJ. This might be this. I don't want to tell you the wrong thing because I'm not 100% sure. But if it's IJ, I think it would just be this sort of direction. But it will not likely give you this sort of notation. They will make it clear what you have to do. So don't worry about that. If it's moving IJ, IJ is like XY, right? It's just the different parts of your axes. What do we do when it's parallel? So if it's moving parallel to I, then you know you've got no j component. So j would be equal to 0, right? So if it's moving parallel to I, it will be moving this way. Notice there's no vertical j movement. So you just set j to 0 and solve for that. That's all you have to do. Yeah, it's not so bad. Awesome. So part 2 for this question is a 6 marker. So let's do the 6 marker. At time t seconds, where t is still greater than or equal to 0, particle q, so notice it is a different particle this time. It moves, so its position vector in meters relative to a fixed origin is given by this equation. Find the value of t at the instant when the speed is 5 meters per second. So, we've done a bunch of integrating up here, but now we're going from displacement to velocity. So, shocker, guess what we have to do, guys? We have to differentiate. So, I'm going to write this out. R is equal to t squared minus ti plus 3tj. This is what it says in the question. I'm just writing it out here for reference. So I need to find t when v equals 5. T when v equals 5. Do I have v? No, but how am I going to find v? I'm going to differentiate r with respect to time. You can also use this notation. I think that's called Newtonian notation, where you just put a dot. That's you're differentiating it once. So if I just differentiate this equation up here with my i's and j's, that just becomes 2t minus 1, and that just becomes 3. So at speed equals 5, this is the important part of the question, and I need to make this very important. Speed. They have told you the speed is 5. That's why this is 6 marks, because you might be thinking, oh, this is not much. Speed, what do we know about speed? That is a magnitude or a scalar of velocity. This is one of the things that trips people up a lot. So if you're taking away something from this, make sure you do this. Pythagoras, exactly. So you know that the speed is going to be equal to the square root of 2t minus 1 squared plus 3 squared. And what did they tell me the speed was? 5. This is my equation, right? Because I'm going 2t plus 1 there and 3 up. So 2t minus 1, sorry, and 3. So the speed is just this bit. If you check my video on projectiles, I did a similar working here. I think it's the last video I posted. You just need to find the magnitude. So if I square both sides and expand this out, I get 4t squared minus 4t plus 1 plus 9 is 10. That's equal to 25. And if I subtract 25 from both sides, I get minus 15 equals 0. And then I solve for t. T is 2.5 or negative 1.5. Shocker. Again, I've got a negative value. So therefore, t is going to be equal to 2.5 seconds. And that is how you do 6 marks right there. Not bad at all, in my opinion, for 6 marks. But yeah. Pythagoras, just get unconditional. Moments is long, but I'm going to teach you an easy way of knowing when to do moments, because sometimes they like to hide moments in those applications of forces questions. This is nice if it comes up. Most likely you are going to get a variable acceleration question. In probably every paper, I think, they have one of this. So maximize your mark on these questions because you're differentiating and integrating, which is pretty nice in a mechanics paper, in my opinion. All right, awesome. That's question 3 done. I think we've got 2 more questions left of this paper. Then we're going to do 2021 paper. So this is the type of question where I'm going to teach you how to know what to do. And I have a video posted of this as well, so you can check that out afterwards if you would like. So this is the question which most people don't like. Can I just know your thoughts in the chat? What do you guys think about this sort of question? Do you like it? Do you hate it? What are your thoughts on this? Just so I know what I'm working with. This is at Excel. Impossible. They're not too bad. All right. I'd leave it. All right. I'm going to show you, Ronnie, that they're not impossible and that you can get a bunch of marks on these. All right. I like it, but it's probably just because yeah, physics does help with these, like knowing how to do. I don't like it when it comes to hinges. Oh, I also hated hinges, but I'm going to see how I can help out with that. So let's start going through this question and we'll see. All mech is beautiful. I agree. All mech is beautiful, but I do not prefer this. So we're going to see how to do this, and hopefully you guys won't be too upset when this question comes up, because I can almost guarantee you a question like this is going to come up. So I'm going to show you how to start. A ladder AB has mass m and length 6a. Straight away, you're thinking mass leads to weight, which is mg. I don't know if it's uniform or not, so I don't know where to label it yet. I'm going to keep reading. The end A of the ladder is on rough horizontal ground. So I like to just do this so I know that it's rough. The ladder rests against a fixed smooth horizontal rail at point C. So there's my smooth horizontal rail. If it's smooth, then I know there's no friction on that rail. All right, and that the normal contact force is just going to be perpendicular. That's that assumption there. The point C is at a vertical height 4a above the ground, shown on the diagram. Awesome. The vertical plane containing AB is perpendicular to the rail. That's basically just saying that this is like flat and this rail is coming outwards out of the page, if you want to visualize that. The ladder is inclined to the horizontal at an angle alpha, where sine alpha is 4/5. Remember, when you see this sort of thing, draw out your triangle, you have 4, 5, oh wow, a 3, 4, 5 triangle again. So then you know that cos alpha is equal to 3/5, and tan alpha, which you normally don't use most of the time, but I'm just going to write it, it's 4/3. The coefficient of friction, oh wow, they're so helpful, it's mu. The ladder rests in limiting equilibrium. Okay, so that's quite helpful. We know that there's going to be a friction max. The ladder is modeled as a uniform rod. All right, cool. So I know it's uniform, so I know where to label my weight. Using the model, show the magnitude of the force exerted on the ladder by the rail at C is this thing here. So now I'm going to start labeling, okay? So I know it's a uniform rod, so my weight is going to be about there. It's going to be M times G. What else can I label here that has not already been labeled? The normal contact force at the rod here. That is going to be, I'm going to call this NC. And I know that it's got a horizontal component and a vertical component. That is what you have to do. Even when you have hinges questions, this is sort of what you want to do. You know that hinge is going to have a horizontal and a vertical component here. What else do I know? Well, the rod is touching a ladder is touching the floor. So you've got a reaction force here, and it's going to slide down, right? So I've got friction as well over here. So how am I going to go about doing this question? There are two things to do. Things to do. You might be wondering, where on earth do you start with this? So either you can take moments, or you can resolve forces. How do you know which one to pick? This is what I learned when I was revising and helped me out. If you don't know forces on two separate points, take moments. You take moments about one of the points, and then you can solve for the force on the other point, right? But if you don't know the forces on one point, then you resolve forces because you just have one missing value. You can make equations with one unknown. That's how you go about doing this. And the 2 points are like point A here, or point C here, or point B. Those are the points I'm referring to, or this point even here. Points where you've got forces acting, okay? So, guys, tell me in the chat, am I going to take moments, or am I going to resolve forces to do part A? Is moments when you have sine, angle for up and down for arc, cos. Yeah, I don't know. You're going to take moments about A. Moments could be for, you use trig with both moments and resolving. So that's not the main differentiation. All right, moments, awesome, right? Because you don't know the forces on A or on C. So what do you want to find? You want the force at C. So you're going to take moments about A. So moments about A. Since you don't know the forces at A, the sum of the clockwise moments is equal to the sum of anti-clockwise moments. How do I know I can use this rule? Well, because they told me it's in equilibrium, right? So that's why moments in equilibrium, you use this rule. So moment is equal to the force times by the perpendicular distance from the line of action of the force to the point. So what is my force? Let's first find my clockwise forces. So I'm ignoring all these forces, and I'm imagining I'm going to swing this down or up with these forces. This force, if I pull it, is going to go clockwise. So this is my clockwise force, mg. Now, what is the perpendicular distance from the line of action of this force? Well, if I imagine extending that, this is going to be my perpendicular distance, right? So I'm going to draw my little triangle here on the side. This is how I lay it out, so it's so clear and easy to work out. I recommend doing this, right? And I need my distances. Well, I know that this is alpha. This is the distance I want. What is this distance here? Well, I know it's a uniform rod, so that's 3a and that's 3a. So this distance here would be 3a. Now, how am I going to figure this out? Well, I just use trig. This is adjacent hypotenuse cosine. So this would be 3a cosine of alpha. That's going to be equal to my anti-clockwise moments. So which of these forces from A would cause it to move anti-clockwise? This one, this force. You imagine pulling this around, it goes anti-clockwise, right? So the force over there is going to be equal to, well, I don't know what it is. I've labeled it as NC. So I'm just going to call it N small c. What is the distance? Well, if I look at this, the distance is going to be this distance over here, the perpendicular distance from that force. So if I do my beautiful little triangle again over there, let me just say, yeah, you guys can see. So that is alpha. What values do I know here? I know that this is 4a, that's the vertical height. And this is going to be x. That's the distance I want. So this is opposite hypotenuse. This is sine. So if I do my little thing, so sine alpha equals opposite, which is 4a over x. So x is going to be equal to 4a over sine alpha. Awesome. And now this becomes a super easy equation to solve. Why? Because we know what cos alpha and all our values are. So I'm going to put those in. So I have mg. I'm just going to save this 1 second. Save. All right, cool. mg times 3a, and they allow me to have it in terms of mg, but the a's should cancel, as you can see. What is cos alpha? Well, I've done that over there. It's 3/5. So that's going to be 9/5 a. That's equal to nc. Well, what is 4a divided by sine a? Well, that's 4a times by the reciprocal of sine a, which is just times by 5 over 4. The 4's cancel. So then you can just say 9 over fifths mga equals nc 5a. Excuse the way I've written this. The a's cancel. Therefore, nc is going to be equal to mg times by 9 divided by 5 times 5, 25, which is 9 mg over 25. That's how you do that question. So it is 3 marks. In my opinion, this should be worth 4 or 5 marks because you're trying to understand what is happening in this question first. But you can see how beautiful and elegant this working is. Why? You know what you need to do. You don't know forces at 2 separate points. That means you're going to take moments. Take moments about the point where you don't want to find the forces. So I don't want the forces at A, I want the forces at C. And then you just have to find the force times by the distances and put your values in. That is all you have to do for that, and they give you the answer. Maybe that's why it's worth 3 marks, but yeah. So how does this look? Equilibrium is talking about moment, a limiting equilibrium. Exactly. Equilibrium is when you talk about moment, and limiting equilibrium is when you're in friction. But here, the latter is resting. It's just resting. As you can see, it says here, rests. So that's why I know that moments are in equilibrium too. Could you go through anti-clockwise and clockwise bits? Sure. So the clockwise and anti-clockwise moments. I'm going to look at the diagram and imagine this is your ladder, okay? I've taken moments about A, so I'm going to hold my ladder at A. You can do this even in your exam. Imagine you're doing this on the table. So you've got a force acting here, right? So I'm going to look at the force and I'm going to see, is that clockwise or anti-clockwise? So it's pulling it downwards. If I pull my pen downwards, you can see it's moving clockwise, right? So this is going to be my clockwise moment. So moment is force times by the perpendicular distance. Well, the perpendicular distance is this distance across because the force goes down there. I just did a bit of trig to find that this was my perpendicular distance there. Now for the anti-clockwise moment, still fix my hinge over here at A. This is the force, NC, ignoring those two small over there. Imagine I'm pulling it upwards. You can see it's going anti-clockwise. So that is going to be my anti-clockwise force, and I've multiplied it by the distance there. That is exactly how you can remember and figure out which force makes a movement clockwise or anti-clockwise, all right? You have to go, imagine you're pulling it in either of these directions. That really helps you, all right? Y is F equals mu times R. Where did I put that? Oh, F equals mu times R, that's the equation for friction, maximum friction. This is the 2020 paper for mechanics. All right, so that's part A. Part B is worth the majority of the marks. And it says, hence or otherwise, find the value of mu. Well, I now don't know the forces at one point. So I can just do resolving forces. So mu is going to be here. That's F R. So friction is equal to mu R. That's the equation of friction we should know from Unit 5 in Year 2. So I'm going to resolve horizontally because that is where mu will be in the equation of. So for part B, I'm going to be resolving this, and I'm going to take my right direction as positive. So mu r is going to be equal to its negative components. What other horizontal forces do I have? This force, you need to remember this force here has got a horizontal component. How am I going to figure out what this angle is? I know this angle is just alternate angle, so this is going to be alpha. And remember, this is acting perpendicularly, so this angle here would be 90 minus alpha, because this is just a right angle on both sides. So this is 90 minus alpha, so this would be the force, which is N cos of 90 minus alpha. Why is it cos? Because this is adjacent to the angle, and this is the hypotenuse. That's Ka from SOHCAHTOA. So this is my equation here. I need to find mu, right? I know what n is, and this is just sine alpha, but I don't know what r is. How am I going to find what r is? I have to resolve vertically because r appears in my vertical equations. So looking vertically, I have that r, which is this bit here, is equal to mg, or sorry, r plus this component here. You can see the vertical component of the normal contact force is also going upwards. So this would be n sine of 90 minus alpha, right? Because this, imagine you're just putting that there. That's opposite. And you're subtracting mg. So if I put that as an equation, you have r plus n sine 90 minus alpha, the same angle I'm using, minus mg, because that's in the opposite direction. We know that that's going to be equal to 0. Why? Because it is at rest. It's in equilibrium. So if I rearrange and solve for r is equal to negative n sine 90 minus alpha is just equal to cos alpha, right? Because we should know that that is the relationship between sine and cosine. Let me just rub out that bracket. Alpha, and I'm adding mg. So I can just plug in my values. Minus n is this thing up here, so that's 9mg over 25. Cos of alpha, what did I say my cos alpha value was? 3/5. So that's multiplied by 3/5 plus mg. If I put this into my calculator, I get 98 over 125 mg as my r value. Now I can super simply solve for mu since I have all the other values. So resolving horizontally again, mu is going to be equal to n, which is 9mg over 25, times by sine of alpha. This thing here is sine of alpha, right? Because remember the relationship. So sine alpha is just 4/5 from the question. And I am dividing that by r, because I've just divided by r in one step. If it helps plugging in then rearranging, you can do that too. So I'm dividing by 98 over 125 mg. And if I put that through in my calculator, the mg's will cancel. I get 36 over 98, which simplifies to 18 over 49, which is equal to 0.367 to 3 significant figures. And this value of mu makes sense. Why? Because mu has got to be between 0 and 1. And that is how you would find mu, by resolving the forces. Does this make sense? Let me just check the chat. Instead of 90 minus x, could you not do 90 minus 90? Whichever way helps you find what the angle you're looking for is, you can do. Like, I like to do it this way because I'm happy with the way that sine 90 minus alpha equals cos of alpha, but whichever way works for you guys, do those angles. I got my level 2 for the math tomorrow. Oh, best of luck with that. Make sure you consider 74 going against gravity or not, because it'll be negative 9.8. 74, where was 74? It's calm. Alright, awesome. So, hopefully this makes sense. This is your little to-do, because starting may be the hardest step. So, if you want to take a screenshot of this or make a note of it, I would recommend 2 things to do. You either take moments or you resolve forces when you see this question. You take moments if you don't know the forces at 2 points, and you resolve forces if you don't know the forces at 1 point. All right, so that is how you do question 4. This question, I can guarantee you some sort of question like this, an applications of forces question, is bound to come up. All right, moving on to question 5. These are my favorite type of questions in the paper. I love projectiles questions, all right? So I will be doing another whole paper, so there's another applications of forces questions in that way. If it asks you to find mu and it wasn't in an equilibrium, then what would you do? If it wasn't in equilibrium, then you would have a resultant force, right? Which means you've got an acceleration. So you would need to use F equals ma and resolve like that. That's a dynamics problem. So this is a statics problem where there's things not moving, but if you've got things moving, like up here, for example, you've got a dynamics problem. You have to use F equals ma. That's what you would do. All right, so projectiles, nice too. I love projectiles. What are your thoughts on projectiles before I get into this? Do you guys like it? Do you not like it? Easy. Don't know what they are. Love projectile motion. All right, projectile motion, it is one of my favorite chapters. I love them so much. The reason they are easy, or could be thought easy, is because you're just doing suvat in 2 different directions. But in one of the directions, you're not even doing suvat. It's just speed equals distance over time, horizontally. So what you need to know about projectiles is you've got vertical movement and horizontal movement, and they're independent of each other. The fact they're independent means we can do two separate columns of working to find it out. And also, horizontally, there's going to be no acceleration. So it's just speed equals distance divided by time. But vertically, you've got acceleration. Why? Because there's gravity. It's going downwards in this case. Gravity pulls everything down. So for vertical motion, you use suvat. Horizontal motion, you just do speed, distance, time. Now let's get into this question. Just take a note. It's being launched from a height at an angle with a speed. This in particular is one of my favorite types of questions. So a small ball is projected with a speed u meters per second from a point O at the top of a vertical cliff. It is 25 meters vertically above point N, which is on horizontal ground. It is projected at an angle of 45 above horizontal. The ball hits point A, where AN is 100 meters, shown in the figure 2. The motion is modeled of a particle moving freely under gravity. It's important to just know what the modeling assumptions are. Using this initial model, show that u is equal to 28. So I need to basically find speed, right? U is my speed. How am I going to find my speed? I need the vertical and the horizontal components of my initial speed. So if I'm going to go vertically, vertical, I need to find the initial speed. What you need to do is, I hate when it messes up. Sorry, give me 1 second. There. What you need to do is resolve horizontally and vertically like we've been doing the whole time. Remember, mechanics is just a bunch of trig and resolving. So this is u. We know that this is 45. The horizontal component of u we can see is that part. That is going to be u cos 45 because it's adjacent. The vertical component is going to be u sine 45 because that's opposite. So how am I going to find what u is? Just start doing your vertical and horizontal columns of working and see where you can go from there. So my vertical motion, write out your S, U, V, A, T values, okay? So S is going to be equal to, well, what is my S value? If it's at the end of its motion, the overall displacement would just be negative 25. Negative 25. I'm doing the entire motion, by the way. I'm considering the entire motion of this. So from O to A. The initial vertical velocity is going to be u sine 45. I'm going to take upwards as positive. Remember, upwards is positive, hence my displacement is negative. Should have said that at the start. Acceleration is going to be negative 9.8 meters per second squared, right? Because if upwards is positive, acceleration is pulling you down to Earth. So it's negative. And t, I don't know what t is yet, so let's see. How do you guys figure out t? Well, you can know that horizontal motion happens at the same time, and because it is going like this, the time taken for its vertical and horizontal motion is the same. So if I know the time horizontally, I can sub that in. So the displacement is going to be equal to 100 meters horizontally. The acceleration, the velocity, sorry, is going to be equal to u cos 45 from this diagram up here. The time, well, how do I figure out time? That is displacement divided by initial velocity. So that's just 100 over u cos 45. So that's my time horizontally. The time vertically is also going to be the same thing. That is going to be 100 over u cos 45. Now, where am I going to go from there? I need to show that u is going to be equal to 28. So I have a bunch of values here, and I need to somehow solve. Here, I can't really do anything else because I've just got an unknown there. But with this, I could find an equation that links S, U, A, and T. That's just going to be S equals UT plus half AT squared. That's the equation. So you can see by clearly writing out my vertical and horizontal motions separately, I can see what the next line of working is. Now I just have to sub in, so that's negative 25 equals u times t. That's going to be quite a big chunky looking thing. So u sine 45 times by t, which is times by 100 divided by u cos 45, plus a half a, I'm just going to multiply that out straight away. Half of negative 9.8 is minus 49 over 10 as a fraction. T squared is 100 over u cos 45 squared. Now don't be put off. Projectiles questions love to use trig identities and obnoxious trig looking things. So I'm going to go through this and see what I can do. So negative 25 equals, well, my u's can cancel here. Sine over cos of any angle, remember that if they're the same, it's just tan. So this is 100 tan 45. And if I evaluate this thing out by squaring it, I get minus 49,000 over u squared cos squared of 45 degrees. So now what am I going to do? I have to figure out what u is, right? So from this step, I am just going to I can evaluate this thing here, right? Because cos squared of 45 is just a number. That is equal to a half in your calculator. So what you saw, I paused there for a second. I was just trying to see in this question, what exactly can I do? So then I have minus 25 equals 100 tan 45 minus 98,000 divided by u squared. Now, what am I going to do here? I am going to bring this onto the left side and add 25 onto 100 tan 45. So by bringing this here and by bringing that there, I get 98,000 divided by u squared equals 100 tan 45 is just 100 plus 25 is 125. U squared is going to be equal to 98,000 divided by 125, which is equal to 784, and you just square root and say, therefore, u is equal to the square root of that, which is equal to nicely 28 meters per second, which is the answer we wanted to prove at the start. And that is how you bag 6 marks nice and easily by just doing horizontal and vertical motions separately. Does this make sense, everyone? Did you all follow along that? Let me just check the chat. I feel like an unpaid mod. Numbrin, thank you so much for helping everyone out in the chat. Alright. Why did you do horizontal? You didn't even use it. I did use horizontal. So remember, when I was doing the vertical motion, I knew S, I knew U, I don't know V, but I don't need to find V. I know A is negative 9.8, but I don't know T. How am I going to find T? Well, I know that horizontal and vertical motion of a projectile takes the same amount of time, right? So here, if I just do my horizontal motion, there's no acceleration, right? So it's just a distance, speed, and time thing. So distance is 100, speed is u cos 45. The time, well, I don't know the time for that, but I can calculate it. It's distance divided by speed. So that's 100 divided by u cos 45. That's why I did the horizontal motion. Even if you don't need to use it, it helps setting it out so you can see the values you have and make the working much clearer. Awesome. This is not further maths. This is just normal standard maths. A-level maths. I love how Braden is responding to everyone. In year 11, I think I'm going to learn A-level maths in summer. Should I do pure or stats and mechanics to get ahead? I recommend doing pure, but you don't need to revise in summer. Enjoy your summer, guys, all right? Enjoy your summer. But if you have to pick pure, because then stats and mechanics is just applied version of that. This is A-level. I'm in the wrong place. Bro, I don't get it, man. Alright, so I'm going to explain projectile basics from the start really quickly one more time. Check out the video. I've created a video exactly like this, I think yesterday or day before, alright? So you need to resolve vertical and horizontal motion, right? Because with projectiles, if you guys have played the game Angry Birds before, you know you're pulling back on a slingshot and launching the bird like this shape, yeah? So it's moving horizontally and it's moving vertically. They are independent of each other. Both of those motions are independent of each other, which means that I can consider each separately, which I've done in my 2 columns here. Vertically, you have gravity acting, right? Because the bird has got to come down. So you've got g as 9.8 meters per second squared. So vertical, I'm going to use suvat like I've done, which is one of the first things you learned in mechanics in year 12. Horizontally, there is no acceleration because there's no resultant force acting on it unless it was being pushed along. But the projectiles are not. They're just shot and done. So that's just a distance, speed, and time calculation. So then I'm just going to set up my 2 columns and see what values I have at a certain point. So for this one, I've decided to do the complete motion, right? So it's going from a height of 25 to the floor. So the vertical displacement, taking up as positive, you need to select the direction, is negative 25 meters. U is going to be equal to U sine 45. Why? Because the speed at this angle is U. I need to resolve yet again horizontally and vertically, so I get these. And A is negative 9.8. Why? Because the acceleration is pulling downwards, and time, I don't know the time here, but because it's moving horizontally too, it's the same amount of time. So I can sub that value in over here for the time. That is how you do that. Now I've set this up, I need to see what do I want to find? U. I can't do anything else over here, but here I could create an equation using SUAT. This equation, sub your values in, fudge around with the trigonometric stuff and see what you can do. Because remember, these are just values at the end of the day. You only have one unknown. So solve for U, and you just square root over there. S is negative. Why? Because, let me see, has Bryn answered? Yeah, Bryn has already answered. I have modeled up as positive. So if I'm going this way, it's increasing. This way is decreasing, hence it's negative 25. Awesome. Thank you, Yuzer, as well for responding. All right, and the projectile starts on a platform. So that is a 6 marker. Very nice 6 marker, in my opinion. I love that because they give you the answer as well. You know, you've got those 6 marks in the back. Part B, find the greatest height of the ball above the horizontal ground NA. Hopefully that explanation made sense, Ronnie. And check my 2 TikToks about projectiles as well. How is the horizontal displacement 100? They have told us that in the question in this line. Find the greatest height. We need to know that at the greatest height, so part B, the greatest height is when V vertical is equal to 0. Because imagine you have your projectile is going like this and is going down. At one point, the vertical velocity is going to temporarily be 0. So I'm going to model resolving upwards, going upwards, and that's going to be positive. So my vertical motion. What exactly do I need to find in this? I think I kind of, yeah. Yeah, find the greatest height above the horizontal ground. It's very important you know that it's above the horizontal ground, which means what? We need to add 25 to this greatest height that we're going to find. So if I find that, my displacement is what I want to find. Remember, write your Suvat values. U is going to be equal to 28, because we know what U is, sine 45, like we did in part A. The final velocity at this point here is 0 because that is when greatest height is reached. Acceleration is negative 9.8 because I've taken up to be positive. What equation links SU, V, and A? That is V squared equals U squared plus 2AS. If I plug in my values, I get 0 equals, oh great. This seems to happen quite frequently. Don't worry. This is over here. So I've got V squared equals U squared plus 2AS. So if I plug in my V, S, U, and A values, I get 0 equals that squared minus 19.6S. Sorry, that S looks like a 5. If I rearrange this by adding 19.6S onto the left side, I get this, and dividing through by 19.6, you get that. So I've just rearranged for the displacement, right? That's equal to 20 meters. But, and I've put that in full caps, you need to add this 25 meters as well, right? Because you want the greatest displacement vertically above NA, above the floor. So if you just add 25 to 20, you get, therefore, the greatest height is equal to 20 plus 25 equals 45 meters. And that is how you do part B. Turning off autosave. No, I don't know what does it. Like, sometimes randomly, it's just gonna, while I'm writing, it just goes away. Autosave doesn't do that. Like, I just need to keep saving it. You'll see, save from time to time. I don't know, even when I've been revising for my iPad before, it's done it. It's just something I've left with. Alright, so that's how you would do part B. So I'm just gonna put the answer to part B over there. Unfortunately, part A is gone. Part B, the greatest height is 45 meters. Part C and D are just refinements to the model. They're your 1 marker. Try good notes. All right, I'll check that out afterwards. Thank you. So, in a refinement to the model of the motion of the ball from O to A, the effective air resistance is included. This refined model is used to find a new value of U. How would this new value of U compare with 28? All right, so now we've got to think. Do you guys want to let me know straight away what you think? Is this new value of U going to be greater than the old one or smaller than the old one? Yeah, that's 9 out of 11 marks. It is a lot of marks for this question. It's very logical. Yeah, follow it step by step. So, the way you would do this part is just have to think about it a bit. So, the movement, they've told us, and this is one of the important things that kind of is confusing. You need to know the movement is from O to A. So, it's still going to go, let me just do that. Beautiful. It's still going to go 100 meters across. But now I have included air resistance, right? So if I have air resistance included, but I still need to make sure it goes 100 meters across, that initial speed has to be bigger, right? To overcome that air resistance. So therefore the new value is going to be greater than the old value. Why? To overcome the air resistance and reach the same distance. You have to read the question carefully for this one. Higher as air resistance, exactly, just a random. Higher as air resistance has to be overcome. So they're saying they're still going from O to A. They still want to do this entire motion. But now you have got something pushing back on that ball. Well, if something's pushing back on that ball and I want to still do this speed, I've got to increase this distance, sorry. I have to increase my initial speed. So the new value is going to be greater than the old value. That's how you do part C. We're not done. There's part D. Ba, ba, ba. All right. State one further refinement to the model that would make it more realistic. Everyone just put in the chat what is one further refinement you'd put. There's one that's really super easy to say, which I would recommend putting. Spin. Awesome, exactly. Everyone try and put down a refinement you would put. Spin of the ball. Air resistance? No. So they will not allow air resistance. Why? Because they have already said it is refined to use it to take into account air resistance. If they didn't say that, D, then you could say that. But because they've said it has air resistance, don't say that, all right? All right. Use a real value. Be careful with that phrasing. Don't say real value. Say more accurate value of g, right? Because we've just taken g to one decimal place is 9.8. But if you want it to be more accurate, you could say 9.81 or so on. Not making it a particle. Exactly. Not making it a particle. Use a more accurate value of g. Size of the ball also. Spin gets the mark every time. It is easy. Exactly. Use a real g. Yup, for 4 letters. Yeah, for 4 letters. Spin. The one, so none of you guys have said this, but the one I put in my final last year, which also gets the marks every time for these type of questions, is wind resistance, taking into account the effects of wind. Because if you're throwing a ball off a cliff, if you've got a gust of wind like appearing here, that ball is not going to follow a projectile path anymore. So that is something else you could say, taking into account the effects of the wind, but that one is context dependent. So you have to think if it's indoor or outdoors or if there would be wind. If it's like this and you're launching it over a cliff, you're going to have wind. That's why you could do that. And that brings us to the end of this paper. Before anyone leaves alive, I am doing another paper now. I just want to say, so that was the 2020 paper. How did you guys find that? Did you find it okay? Did you like it? Did the explanations help? Yep, I'm going to try and upload this by tomorrow morning on my YouTube channel. I've got the same handle on that as well. I'm a user because yeah, it's consistent, right? Consistency, make it easy. And it's got the same profile pic and everything. Awesome. Thank you for the roses and the gifts. I really appreciate all of your guys' support. So I'm just going to put starting soon on this one. We'll have a few second break now. I wrote sun. Starting soon. Just gonna have a few second break while I don't lose my voice. I'm gonna have a little drink. But yeah, share the live if you're finding it useful and stuff like that that people who do lives normally say. I'm not trying to promote it, right? You know. Does anyone have any questions or any advice or anything they want to share about exams? How's it going? How have your exams been recently? I think what was it? Today was physics paper 3. If anyone did physics paper 3, how was that? I heard OCR kind of screwed people over. Again, exams have been beautiful. I'm so glad. Paper 3 was good. I'm so happy to hear you guys have had good paper 3s. Now you guys are almost done. Why do schools do AS exams? I don't know. I think It's just choice, right? Ethics of physics was all right. Awesome. AQA was solid. Yeah, I think AQA was bad for paper 2 for some people, but yeah, this is year 2. This is A2 content. Hey Keanu, welcome to the live. So yeah, I'm gonna get started. Got 22 people in. Gonna not waste any time. Hopefully that doesn't drop, but it tends to. So we are going to do the 2021 mechanics paper. I did the 2021 stats paper yesterday. That recording is posted on YouTube, and I'm going to post this recording on YouTube hopefully by tonight or by tomorrow morning, depending on how many hours it wants to take. All right, let's jump right into it. So, question 1. A particle P moves with constant acceleration. Oh, look, they've already told us. Nice. 2I minus 3J meters per second squared. Next to that, put the letter that represents it. So you have to put A over there. At time t equals 0, so t, P is moving with a velocity of 4I meters per second. So put your letters so you can see. So constant acceleration means what? Suvat. Awesome. Now I've understood the question. Find the velocity at time t equals 2 seconds. So this one, you know, is constant acceleration. So you can just use suvat. What letters do I have? This is not v actually. This is at time t equals 0. This is going to be u. So I need to find v. What equation links v, u, a, and t? I want someone in the chat to let me know actually. Because this is something that you should all know by heart instantly now. Equation linking a, t, u, and v. Yeah, you can use Suvat. It is much easier. Don't integrate or differentiate this one. I would not recommend that. It's just long. V equals U plus AT. Yup, nice. That should just be instantly in our minds. So just plug in your things. I'm going to do it in the IJ notation because I did column vector notation before. So U is 4I plus A, which is, what is my acceleration? That, 2I minus 3J times by t, which is 2, so I'll just put that in front of the bracket there. If I expand out, I get 4i plus 4i minus 6j, and that is simply equal to 8i minus 6j meters per second. Beautiful 2 marks to start off the paper. Make sure you don't waste time, but also make sure you get the question correct because you want to guarantee the easier marks in the exam. Of course you do, right? So, at time t equals 0, the position vector of P, so I'm thinking the letter R now, right? Of P relative to a fixed origin is that. This is going to be R naught. Why is it going to be R naught? Because look at this, t equals 0. That means at the start. So at the start, its initial position is I plus j. Find the position vector, so R, of P relative to O at time t equals 3. So notice it's saying relative, you have to take into account its initial position. So with these, I always write down suvat, but this is now ruvat because it's vectors, and tick off the values I have. So I want R, I have U, I don't have V, but I've got A and I've got T. What equation links R, U, A, and T? R equals U, T plus half AT squared. Notice I've left this space. What have I left this space for? R naught. That is my offset because I've not started at the origin. You need to make sure you have R naught. All right. So then if I just put this in, I'm going to do this one using column vectors because it's longer. So R naught is IJ, so 1 and 1 on both, plus UT. Well, what is U? U is going to be equal to 4 in the I and 0 in the J. What is my time? 2 seconds plus half. And what is my acceleration? 2 minus 3. 2 minus 3. And what is t squared? Well, t squared is this value here, squared. So times by 9. So that is going to be equal to, if I just do this part and this part separately, that's 1 plus 8, which is 9. Actually, I'm just going to do it all together because I've got the answer right. So that's going to be equal to 13 and 1 plus 9 and minus 27 over 2. If I just do my vector multiplication and vector addition, remember, if you're multiplying by a scalar, so 9 over 2, you multiply the numerator, the I component and the j component by that. Same here. You can add the i's and j's separately. When you add this, you get 22i minus 25 over 2j meters as your position vector, because that's what r is, right? And I like to answer in the form they've given, IJ notation here, and that's how you get a nice 4 marks to start off. The main thing you need to be worried about this question, not worried, look out for in this question is this, are not. That is the thing where most people are going to forget to do. So make sure you know you have to add are not. I'm going to just check the chat. This is year 2 content. You did this question earlier. Yeah, so this is year 2 content. This is at the end of the year 2 textbook, the last chapter. Awesome. Everyone happy with this question so far? I am going to go on to question 2 now. This question, police questions. What are your guys' thoughts on police questions? Do we like them? Do we not? They're kind of long, but they all work the same way each time. When you use r equals r naught plus vt, when can you use that? So that one is only for, so you only use suvat for constant velocity. You use that one if you have an offset for r. So if it does not start at the origin, offset just means it's like offset from the origin. So that's when you add the r naught. We love police questions. Can you post some of these clips on your page soon? I'm gonna upload my live. Start uploading it by tonight. Hopefully it'll be posted by midnight, I say, but by tomorrow it'll definitely be on my YouTube. But yeah, I covered stats yesterday. If you check out my YouTube, I've posted the recording there, and I'm going to do stats and mechanics tomorrow. Both of them, one more paper tomorrow. All right, no worries. I'm glad you're interested. Makes me happy. I integrated part A and got it wrong. So if I were to integrate that, I'm going to show you the integration method real quick. I haven't planned this, so if I make a mistake, let me know. So acceleration is 2i minus 3j. Velocity is 2ti minus 3tj plus c at t equals 0. T equals 0. The velocity is equal to c, which is equal to 4i. So therefore, v is equal to 2t plus 4 and minus 3t. And I need the velocity at t equals 2. So that's going to be 2 times 2 is 4. 4 plus 4 is 8 minus 6. Boom. Yeah. So if you are doing the integration method, so this is using integration, this is how you would do this. All right. Same handle, a user. Thank you, Bryn. I should make you moderator. I don't know how to do it, but yeah, my YouTube is the same. Yeah, same character. So yeah, you have to be very careful. So that's how you would integrate it, but use suvat. How'd you get that v part, this part over here? Because I need to know a boundary condition. My boundary condition here is at t equals 0. The velocity, initial velocity, is 4i. That's how you do that. Awesome. Moving on to the police questions. So they're long, but they work the same way each time. A stone of mass stone A of mass 3m is attached to one end. Stone B of mass m is attached to the other end of a string. Initially, A is held on a fixed rough plane. It's important to note that you've got friction happening here too. Plane is inclined at an angle tan alpha. Remember, you draw your little triangle there. That's 3, 4, again a 3, 4, 5. They love 3, 4, 5 triangles, all right? So sine alpha is going to be opposite over hypotenuse, that's 3/5, and cos alpha is going to be equal to 4/5. The string P passes over a pulley P fixed at the top of the plane. The part of the string from A to P is parallel to the line of greatest slope of the plane. That just means that this is parallel to this. There's no like wonkiness or anything. Stone B hangs freely below P as shown in figure 1. So it's freely, that means you've not got it touching anything, so it's not going to rub against the side there. The coefficient of friction between A and the plane is 1/6. So label that as mu. That is good. They've given a mu value. Stone A is released from rest and begins to move down the plane. So I'm going to label the arrow there so I know which direction the pulley is moving in. The stones are modeled as particles, the pulley is modeled as being small and smooth, and the string is light and inextensible. You should all be very familiar with these modeling assumptions already for these things. So using the model for the motion of the system before B reaches the pulley, because that's just going to mess things up, write down an equation for motion for A. So when I was doing part A, I did a lot more than I should have. So I just looked at the mark scheme and it accepts just literally the first thing. So when you are doing equations of motion, you need to label onto your diagram the forces. So the force acting on the mass is the weight. So I've got 3mg this way. So this component is going to be 3mg sine alpha. And the normal reaction force is going to be this version there, which is just going to be 3mg cos alpha. check out my video on resolving forces if you want to see how that works. What else can I label here? I can label that this has got a weight of mg, and I've got a tension acting in this string and a tension which is the same in that string as well. Why? Because the string is inextensible and the pulley is smooth. So I need to just find an equation for A. What am I going to do? I need to resolve horizontally, well, parallel to the slope, and use F equals ma. So since it's moving down, I'm going to resolve down the slope and F equals ma. So what is my forces acting down the slope on A? I've got 3mg minus T. You have to remember you've got a tension force which is in the opposite direction to motion, so you are subtracting that. Minus T. Do I have anything else? I seem to have forgotten to label it, which I did intentionally. Did anyone in the chat let me know? No, no one said. I forgot to label the friction, right? Because there's friction on this. So friction is also going to be going this way, Fr. So I'm going to do minus friction. I like to write my friction with an Fr. That is equal to mass times acceleration. My mass is 3m. My acceleration is a, because I don't know that yet. And boom. Apparently, that gets you 2 marks. What I ended up doing was I continued to find what some of these values were and then rearranged it. But this gets you the marks, and that's it. All right, cool. 2 marks. Not a lot of working. Show that the acceleration of A is 1/10 g. So from that, I just need to solve for A from this equation. How am I going to solve for A? I'm going to rearrange this and plug in the values I know. So 3mg just stays as is. Sine alpha, I know from over here, is 3/5. So I'm going to write 3/5 multiplied by 3/5 minus tension. I don't know what tension is yet, so I'm just going to leave tension as is. Minus friction, which is mu r, is equal to 3ma. I'm solving for this, remember? So that's just going to be 9/5 mg minus tension minus mu. They told me the question was 1/6. And what is my r going to be? That's the normal reaction force, which is just 3mg cos alpha. 3mg cos alpha. That's equal to 3ma. And now I'm going to just evaluate this through and rearrange. So just going to quickly write 9/5 mg minus 2/5 mg, subbing in for cos alpha there. Minus tension equals 3ma. Therefore, 7/5 mg minus tension equals 3ma. From this, I have got 2 unknowns, T and A. If I have 2 unknowns, I need 2 equations. What is my other equation going to be? Notice it is a 7 marker. You got a bunch of work to do for this. The only other equation I can make is the equation for particle B, because they're both connected by a pulley, right? So what is my equation for B? I'm going to resolve upwards. So for B, resolving upwards, I have the tension subtracting the weight is equal to the mass, like F equals ma, is equal to the mass, which is m, times the acceleration, which is a. So if I rearrange this for t, I get t equals ma plus mg. The reason I've rearranged for t is because I want to find what a is equal to, right? So if I could replace t here with t in another form, I would just have an equation where a is my only unknown. So I'm going to sub this into this equation over here. So I then get 7/5 mg minus ma minus mg, because I'm subtracting t. So they both are negative. That is equal to 3ma. If I just do 7/5 mg minus mg, I get 2/5 mg, and I'm going to just cancel out all my m's in this stage too. So that's 2/5 g is equal to, and I add a onto both sides, so that's 4a. Therefore, a is equal to 2/20 g, which is 1/10 g. And that is all you have to do for 7 marks. That is a very nice 7 marker, because all you have to do is simultaneous equations, right? You need an equation for A and an equation for B, and you know that the tension and acceleration are unknowns, so just sub one in for the other and solve, and they've given you the answer. So when you're doing the exam, if you see that the answer is there and you got those, you have 7 marks in the bag. You should be feeling good, all right? Does this question make sense, everyone? Let me just check the chat. Thank you, everyone, for following my account. I mean, I appreciate all the support. And Bryn, also, again, thank you for replying to the comments. Hopefully you're also like understanding everything. Don't worry if you like you can reply to all the comments. You can also do yep simultaneous. Exactly. Awesome. 7 marks in the bag. Part C and D are the questions that we don't tend to like in the papers. They're the logicking ones. I love mechanism, my man. Awesome. So we're just chilling here. All right, C. Sketch a velocity time graph for the motion of B from the instant when A is released from rest to the instant just before it reaches a pulley, explaining your answer. So, if I look at this pulley, I've got B being pulled up, right? The acceleration of B is the same as the acceleration for A, right? Because that's one of the modeling assumptions that we know with pulleys. So I can just say, I'm going to go down here and start doing part C and write with a pen, not a rubber. The acceleration of B equals the acceleration of A, right? And it has constant acceleration the whole time. So just what I'm doing first, thinking about the movement. The acceleration is constant, right? Because A is not changing. That would be variable acceleration. And in A-level maths, they're not going to do variable acceleration on a pulley slope. So that means that therefore V is going to be increasing in a linear fashion. In other words, a straight line, right? And where am I going to start? From V equals 0. Why? Because it starts from rest. So if I just do my axis for my velocity time graph, so I need to label my axes. There's the time in seconds, and there's my velocity in meters per second. I know that I'm starting at the origin, so that's going to be 0, 0. And I'm increasing. It is a constant acceleration. So that means that the velocity is increasing constantly. Why? Because the gradient of a velocity time graph is acceleration. And this is what you have to do. So you need to state your reason and you need to draw your graph. And that's how you do that. It's bad I got the first question wrong for paper 2. First question wrong for paper 2. Don't worry about getting questions wrong. I'll be honest, in one of my papers, I think I struggled on the stats paper. I struggled more with the first question and found the rest of the questions much easier than the first. Don't be put off if you struggle with the first questions. Just remain motivated and continue. All right. So that's part C. Does that make sense, guys? Like why it looks like this and that explanation you give? Let me know if there are any questions. So for part D, this is the assumption question. In reality, the string is not light. State how this would affect your working in part B. So what is my working part B? I've just found 2 different equations and done a simultaneous equation. So if the string is not light, then the tensions in the equations are different. So because then the tension in A, therefore, is not equal to the tension in B. That is how it would affect your working, and you wouldn't be able to do a simultaneous equation where you plug in. So yeah, that's what you have to do for that. The tensions are not going to be the same if the string is not light. Check out modeling assumptions, unit 8 for all those, and then they tell you some more assumptions in the pulley section as well, the second last unit in the year 1 textbook. All right, so yeah, nice police question. Beautiful 9 marks that they give you for just maths. You guys can get those in the bag. Awesome. This type of question again. So remember, this one is a bit weird. Do not be put off by the fact that in the question you see a weird trig thing down there. It's all good because you know you're going to have trig here. Do you think there'll be some random pure stuff in applied? Tension will increase. I don't know what is going to happen to the tension. So the tension could increase or decrease on either side. We don't know. It depends on that string. And AM, they can't, but the NXL have been weird lately because in the 2023 stats paper, they had you doing a normal integration type question, right? So they can't, but they could because I think in the specification it says at some point that doing paper 3 assumes all knowledge from all the previous content, so they could. Remember, if you looked and were in my live yesterday, they had a probability. I'm going to show you actually. Sorry for going off on a tangent. Very, very quickly. Stats paper 1 and question paper, they had an arithmetic series question here. You can see over here, they have a common difference D in an arithmetic sequence. The first four terms are angles of a quadrilateral. You have to find the probability. So they binomial expansion, they could, if you have an algebraic binomial distribution, who knows. But you can see I did an arithmetic sequence working over here. So that is pure stuff. So you need to remember this sort of stuff. Like you need to remember either this formula or this working and know how an arithmetic series works. So remember your pure and your applied stuff. Don't forget that. Let me just go back to the mechanics. Sorry for the little tangent. But yeah, know your stuff. Because Edexcel are on something. So, question 3. We love these type of questions. Why? Because we know we're either doing moments or we're resolving forces. We need to decide which one to do. So, reading through the question, beam AB has mass m, length 2a. The beam rests in equilibrium with A on rough horizontal ground with B against a smooth vertical wall. So, it's smooth. The wall is smooth. Therefore, no other forces except the normal reaction force. So, and I know that the floor is going to be rough. I like to denote rough surfaces like that, just so I know. The beam is inclined to the horizontal at an angle theta, as shown in figure 2. The coefficient of friction between the beam and the ground is mu. The beam is modeled as a uniform rod resting in a vertical plane perpendicular to the wall. That just means that the picture is what you're expecting to think in real life. Use the model, show that mu is greater than or equal to 1 over 2 cot theta. So now, the thing that's off-putting here is the fact that you're showing an inequality. But just think of it as an equation, right? You're just trying to find what mu is equal to, and you know that it is in equilibrium because it rests in equilibrium there. So, first thing first, label your forces. You know it's uniform so that the weight acts at its geometric center, which is there. So that's mg. And I'm going to split this. I've got A and A on either side of that. On the floor, I've got a normal reaction force. I'm going to call that R. And I've got friction, right? If you've got a rod leaning against the wall, it's likely to slide down the wall. So the friction is going to act in the opposite direction, mu R. And on the here, you've also got another normal reaction force. I'm going to call this one N. And there's no other forces acting here because it's smooth, right? If it wasn't smooth, if it was rough, then you would have a friction force acting upwards as you fall down the wall. But we don't need to worry about that here. So, I need to show that mu is greater than this. Well, what do I know has my equation for mu? This bit. So I'm going to resolve horizontally. So I know that mu r, and now I've got what is my other horizontal force in this diagram? This n value, right? That is my only other horizontal force. That the friction is going to be greater than this normal force. Why? Because it's holding it in place, right? So you could say it's equal, but it can also be greater than or equal to this normal force. And it's important you start using this notation here because that's what you want to prove. I think the mark scheme is a bit funny about if you use an equal sign and switch or whatever. But yeah, know that this is here. Why? Because the friction holds it in place. That's the reason I've said is greater than or equal to the normal contact. So now I need to find what R is and what N is. So how am I going to do that? Well, R I can find by resolving vertically. So R, resolve vertically, I get that R is going to be equal to, well, what are my other vertical forces? mg, that's it. So R equals mg, awesome. Now I need to find what N is. How am I going to find what N is? Remember, N is that there. I've got how many points? A, midpoint, and B. I don't know what the forces are at A, and I don't know what the forces are at B. I don't know what two forces are at two separate points, so that means I have to take moments. So, moments, and I'm going to put, because IDK forces at 2 points. So I'm going to take moments about A, so moments, about A, because I want to find N, right? That's the moments at point B. So I'm not going to take moments about that. So the sum of the clockwise moments equals the sum of the anti-clockwise moments because it's in equilibrium, rotational equilibrium. So the clockwise moments, looking at my rod, imagine you have your pen and you're holding it at point A. This force over here is going downwards, so that is going to be a clockwise moment. So the force is mg, the perpendicular distance is going to be this distance over here in the diagram. So I'm going to draw my little triangle on the side and work that out. So force, so I've got x is what I want, theta. What do I know from that? Well, I know that this section is A because it's at the midpoint because it's a uniform rod. So that's just A cos theta. And remember, I don't know what theta is. I'm just trying to show something theta. The anti-clockwise moments, well, I look back up here, this is going to be pulling it this direction if I pull that pen. So that is my anti-clockwise force. So that is N times by the perpendicular distance. What is my perpendicular distance? It is this distance over here. So I'm going to do, again, my little triangle on the side because it shows the working is clear, right? So I need theta. I want that. This is x. And what values do I know? I know that the length of the rod, or whatever it is 2a. It's a beam. So 2a. So that is opposite and hypotenuse. So that's sine theta equals opposite x over 2a, which is just 2a. So that is multiplied by 2a sine theta. Now, I'm going to go back to the question. What am I trying to find? N. My a's can cancel out there. So n is just going to be equal to mg cos theta divided by sine theta. Sorry, divided by 2 sine theta. All right, so therefore, n equals a half mg, and what is cos theta over sine theta? That is cot theta, remember? Because sine theta over cos theta is tan theta, but this is an inverse. This is the flipped trig function, so it's going to be cotangent. That's what you do. So now this is looking like what I want in my answer. So now I just need to plug back into this. So I've got mu r. This implies that mu r is greater than or equal to n. Plug in my r value, plug in n. So mu times by mg is greater than or equal to a half mg cot theta. My mg's cancel, and I know that the sign does not flip because mg is always going to be positive here because of my assumptions. So mu, therefore, mu is going to be greater than or equal to a half cot theta. And that is how you prove this thing. Sub in and cancel through. Yeah. So that is how you do that. Does that make sense, guys, for how we did part A? So remember, it's exactly the same as what you're doing anytime you do this question. You're taking moments on this question, and you've just got a bit more unknowns. See the equation for what you want to solve, then plug into that. You see how we kind of work backwards? So we knew that mu r was greater than or equal to n, found r, found n, plugged in, boom, did that. Awesome. So part B is also worth 5 marks. Now we have to be I've made a note in red on my notes. Be careful. So a horizontal force of magnitude kmg, where k is a constant, is now applied to the beam at A. So it's going to be applied over here. This force acts in a direction perpendicular to the wall and is towards the wall. So this force is going to be there, all right? Given that tan theta is 5/4 and u is a half, so they've given me the values from the part A that I didn't know, sorry. And the beam is now in limiting equilibrium, that means FR is max. Use the model to find the value of K. Now, I'll admit, I did this wrong the first time, which is why I need to warn you. Think about this. This is where mechanics becomes mechanics and it's not pure maths. I'm going to ask you guys in the chat to let me know. If you've got a rod leaning against the wall and you are going to be pushing with a force towards the wall like this, which direction is the friction going to be acting in? Is the friction going to be acting towards the right or towards the left in this diagram? If I have my new force, which I'm going to put in red, so is my friction acting to the right or to the left? It wants to oppose the force, which is why the friction is now acting to the left. Exactly, guys. So glad you picked up on that. So that is the main mistake with this question, which is really evil, but you need to know mechanics. You need to think what exactly is happening. Visualize it, all right? And just always know friction opposes motion. So I'm going to redraw this diagram. It doesn't take me any time at all, so do that in the exam so you have clear working. B, I'm still in red. So I have my little wall there, and I've got my rod, and I'm not going to label all the points unnecessarily. So I know that I've got a reaction force there, and I know that kmg is being applied in this direction. I've got my weight over there, that's mg. I've got a normal reaction there. I know that friction is acting, like you guys said, to the left to oppose the motion. All right, so if you're pushing something to the wall, it wants to go that way, but since friction is opposite, you have to change the sides. So now, if I resolve horizontally, they want me to find, let me just refer back to the question, find the value of K. All right, cool. All I have to do is resolving, because I know forces, I just don't know forces at one point. So, resolving horizontally, you've got kmg, which is my right. I'm going to take this one as positive. That is going to be equal to the negative forces, which is friction and N. So that's Fr plus N. So kmg is equal to, what is Fr? The equation is mu r. And what is my value of N? Well, I found N up here. So that is just a half mg cot theta. So now I can replace mu r, which is kmg equals mu, which is a half mg, which they've told me in the question up here. Mu is a half, r is mg, plus a half mg cot theta. Cancel through your mg's to speed up your working. Then you have k is equal to a half plus a half cot theta. You are so close to the answer now, right? So what is cot theta? Well, they told me tan theta is equal to 5 over 4. Therefore, cot theta is just the reciprocal, which is 4/5. So that's a half plus a half times by 4/5, which is equal to 0.9 as a decimal. And that is how you do it. So this is 5 marks worth of working. This is also 5 marks worth of working. The reason this is hard is because you need to know and clock that friction is going to be acting in the other direction because you're pushing this rod towards the wall. So friction will be acting away from the wall. Yeah, but overall, I agree, Charles. It is a beautiful question, and it's worth 10 marks. That is 1/5 of your paper. Well, 1/5 of your mechanics paper, 1/10 of your whole paper. So yeah, does this make sense, guys? Does anyone have any questions about how we did this? Or are we all good to move on? I think we got 2 questions. Yeah, integral doesn't even look bad. Yeah, the integral, yeah, it wasn't too bad. It was just kind of random, I guess. That's what threw people off. But yeah, don't get thrown off with whatever is in it. All right, awesome. Gonna move on to question 4. I think we got 2 questions left. Projectiles question and then a dry looking question. Do you guys want to do question 5 and then question 4 or just go in order? Because I'm not gonna lie, I want to kind of finish off on a fun question, which is this one. Ba-ba-ba. Do you guys want to do question 5 first, which is this question, variable acceleration question, or do you want to do question 4 first? Which one do you want to do? First person to respond will do that. Do 5. All right, cool. I agree, because I want to end on a fun thing, which is projectiles, which we love. Okay, 5 then 4. Glad I've got a whole consensus. So, at time t seconds, a particle has velocity v, where v is equal to this. Look, I've got t's there. That means I'm dealing with variable acceleration, which means I have to use calculus. In other words, integrate and differentiate. I do not want to do SUVAT, all right, for this question. So find the acceleration of p at time t seconds where t is greater than 0. Well, I know that velocity is the rate of change. Well, acceleration is the rate of change of velocity, right? So acceleration is dv by dt, which I could just represent as v with a dot. That's another notation. I just have to differentiate my equation. So that is going to be 3 over 2t to the minus a half I minus 2j meters per second squared. And it's at time t seconds. That's at time t seconds. Boom. 2 marks. Easy 2 marks, guys. You got that. Part B. Find the value of t at the instant when p is moving in the direction of ij. In the direction of I minus j. So this one, don't read this as ij, read this as I minus j. I think someone wrote a question before, what does ij mean in the chat? I dash j is I minus j. All right, so I need when it's moving, that's telling me about the velocity, right? So I need the velocity, which I know is equal to 3 over 2 t to the half and minus 2t. That has got to be in the direction of 1 minus 1, and I'm putting a scalar there. Yeah, question mark. This is what you were talking about. Awesome, it came up. I'm going to go through this. So this lambda is telling me it's a scalar of this vector. So if lambda was 1, it would just be 1 minus 1, so it would be that. If lambda was 2, it would just be a bit longer. That lambda just tells me it is in that direction, all right? So now I need to find the value of t. Well, how am I going to find the value of t? Well, let's just do two equations. So 3 over 2t to the half equals lambda, and negative 2t equals minus lambda. So I know that lambda is equal to 2t from this. Boom. So I can just substitute in lambda into here and solve for t, and then I'm done. So that's simple working for 3 marks. Equals 2t. All right, so I'm gonna change that to become 4t squared minus 9t equals 0. So I've just multiplied through the whole thing by 2, and then I've squared both sides to get that, and rearranged to get them all on one side. And then you can factorize out a t, so you have t 4t minus 9 equals 0. And because t is greater than 0 and t is not equal to 0, t is going to be equal to 9 over 4. So the way we did that question is, we know it's moving in a direction of 1, negative 1, because I minus j is that thing there. Is going to be some scalar of it. What is that scalar going to be? Then replace with that scalar and solve an equation for t. Nice. Why is the top one differentiated when the bottom one isn't? It should be 3t. Did I make a mistake? Sorry. Did I make a mistake, guys? T to the minus f minus 2, and then v equals... Yeah, I did make a mistake. My bad. 3 over there, and ignore that. I was wondering, like, I was looking at my notes, and I was like, where does that 4 go? There we go. Okay, I've corrected it. Awesome. So that is how you solve for t right there. I think I'm gonna just check my notes. This should be all correct. Yeah, awesome, cool. Moving on. So at time t seconds, where t is greater than 0, the position vector, so now I'm thinking the letter r, of p relative to a fixed origin is r meters. Wow, they've told me that. When t equals 1, r equals minus j, find an expression for r in terms of t. Now I have been given the middle equation, v. So to go from v to a, I differentiate. To go from v to r, we have to integrate. So part c, r is going to be the integral of the velocity with respect to time. So if I integrate velocity, increasing the power by 1, dividing by the new power, I get t to the 3 over 2, 2i minus t squared j. And remember, it's an indefinite integral, so you need plus c. And now how am I going to find that plus c? Well, I'm going to look at any conditions. Do I have any conditions given? At t equals 1, they give me that r equals minus j. So that's my boundary condition. So at t equals 1, r is going to be equal to 2i minus j plus c, and that is equal to minus j. Therefore, c is just equal to minus 2i, right? Because to go from this to this, you have to subtract 2i to get rid of that bit there. So therefore, the equation for r is going to be equal to 2t to the 3 over 2 minus 2i minus t squared j. And that is how you would find the equation for r. All right? How does that work? Does that make sense, guys? Awesome. So, yeah, I apologize for that mistake. It didn't. I'm glad you guys caught it though, which is good. Yeah, I'm glad you're paying attention to what I'm saying. So, part D. Find the exact distance of P from O at the instant when P is moving with a speed of 10 meters per second. This word speed is shouting at me that it's a scalar. Again, common mistake, not taking speed as a magnitude. You need to make sure that speed is the vector. So I need the time when the speed is 10, right? So I can find the distance. So for part D, the time when speed equals 10, well, I know that velocity, and I'm going to write the equation correctly this time, is 3t to the half I minus 2tj. All right, I think that is it. That's correct. Yes, it is. So the speed is going to be equal to 10, which is the square root of 3t to the half squared plus minus 2t squared, right? Because you're squaring your I and your j components, you're just doing a bit of Pythagoras to find the scalar. Square both sides, you get 100 equals 3 squared is 9t to the power of a half squared is just t plus 4t squared. Now I just have to solve a nice little quadratic. You get two answers. You're going to get a negative because you need to disregard one of them. If you don't get a negative, they will have some condition where t is less than the value or t is between certain limits. That's how you just disregard if you got two positive values, by the way. So t is going to be equal to 4. So now I know that at t equals 4, the speed is going to be equal to 10. What do I need to find? I need to find the distance when the speed is 10. So the distance at t equals 4. So at t equals 4, r is going to be equal to 2 times 4 to the 3 over 2 minus 2i minus 4 squared is 16j. That is going to be equal to 14i minus 16j. Have I answered the question now? I'm going to tell you, no, I have not. Because again, notice distance is also a scalar. Speed and distance are both scalars. There's a reason this question is worth 6 marks. You got to do a bunch of scalar stuff. If a question is worth more marks than it looks like it should be, check. Do you need to deal with scalars anywhere? And go with that, all right? The wording is very precise with these questions in mechanics. So, therefore, distance is going to be equal to the square root of 14 squared plus 16 squared, right? Because that's 14i minus 16j. That is my distance. That is just going to be equal to 2 root 113 meters. Because they wanted the exact distance, I'm going to leave it as a surd. And that is how you would do this variable acceleration question. This, in my opinion, is like a model variable acceleration question because you've got a bit of differentiation, a bit of integration, a bit of parallel movement, and finding distances with a bit of problem solving. But yeah, how does this look? Does this look good? We all happy with this question? In my opinion, if you got a question like this worth how many marks? 14 marks, I would be super duper happy. All right. So I'm gonna go and do the final question, which we all said we wanted to do question 4 last. It is a projectiles question because projectiles is my favorite thing. Never simplify a surge, just put in the calculator. Exactly, never do that. Just use your calculator for that. So I'm just gonna have a little drink while you guys can read the question because my mouth is so dry. All right, cool. Thank you for waiting. So projectiles question is another one where we're launching it from a height, which looks kind of similar to the one we just did in the previous paper. A small stone is projected with a speed 65 meters per second from O at the top of a vertical cliff. It is 70 meters vertically above point N, and N is on horizontal ground. It is projected at an angle alpha above the horizontal, where tan alpha is 5 and over 12. So that's 5, 12 there. This is a 5, 12, 13 triangle, which is also another combination they like to do. So then I just put straight away sine alpha is 5/13 and cos alpha is 12/13. Do that straight away at the start of the question, just so you know you've got that there. You can just draw it in straight away when you need to use it. The stone hits the ground at point A as shown in figure 3. The stone is modeled as a particle moving freely under gravity. Acceleration due to gravity is modeled as having a magnitude of 10 meters per second squared. That means do not use g equals 9.8. Use g equals 10. Pythagorean triples, exactly. They love Pythagorean triple triangles. Sometimes you may get a surd. Don't be put off by that, all right? So you have to use 10. In the exam, I would recommend writing g equals 10 in big on top of your page, just so your eyes are drawn to that. Love a cheeky 4, 3, 4, 5. I love those triangles. So nice. All right, so put this in the top. I cannot tell you how helpful something like this is in your exam because I've done massive text in my thing. It helped me when I forgot things nearly. All right, cool. Reading the question, find the time taken for the stone to travel from O to A. So I need to find the overall time for that. Remember, with a projectiles question, we're just going to do horizontal and vertical motions separately. For this one, I can easily just do the vertical motion and find when the vertical displacement goes from 0 to negative 70. So, part A, doing my vertical motion first, and I'm going to take upwards as my positive, okay? So my displacement, because I'm going down, is going to be negative 70 meters. My initial velocity, well, I need the vertical velocity, right? So here I've got a speed of 65. So this is going to be my initial velocity. That is 65 sine alpha. That's 65 sine alpha meters per second. My final velocity, I don't know. My acceleration is going to be negative 10. Remember, I'm looking at this thing up here. G is going to be equal to 10. Why is it negative? Because I've taken upwards as positive, and G, acceleration due to gravity, always acts downwards. Hence, it's negative. And the time, well, that is what I want to find. Awesome. I've got 4 variables that I've been putting into equation. What equation links these all? S equals ut plus half at squared. Most of the time, they love using this equation because it gets you to do a quadratic. So plug in your values, nice and easy. U is 65. What is sine alpha? Well, I wrote it at the top. 5/13. 5/13 times by the time minus a half of acceleration, which is the 10, so that's minus 5t squared. And now if I just rearrange this quadratic, I get 5t squared minus 25t minus 7t is equal to 0. I've just brought the right-hand side onto the left and multiplied through. So therefore, solving this quadratic in my calculator, t is equal to 7 or negative 2. Time cannot be negative, so put an x under that and say therefore, t is equal to 7 seconds. And that is how long it takes. That is 4 marks. Beautiful 4 marks, right? Now, part B, find the speed. Speed, put underneath or above, scalar. Okay, so you need both components of it. Of the stone at the instant just before it hits the ground at A. Okay, so you need the horizontal and the vertical speeds at that point. So I'm going to do my horizontal first because if I have to deal with both, I like doing that first. It's easy. So horizontal, the speed is going to be equal to, well, look back at this triangle here. This is the horizontal motion, that's 65 sine alpha, cos alpha, my bad. Can I undo? All right, so 65, oh my god, 65 cos alpha. You get the point. 65 cos alpha is my horizontal initial velocity. 65 cos alpha. And remember, if something is being projectile motion thrown, there is no horizontal acceleration. It is going to be constant. So that is just going to be the final velocity as well. So the 65 times cos alpha was 12/13, which we found on my triangle above. That's going to be equal to 60 meters per second. Cool. I found my horizontal final velocity. I need my vertical final velocity. So vertical motion now, I'm going to take upwards as positive still, just for consistency. V equals U plus AT. The reason I'm using this is because you can see over here, I've got the rest of the values. T is now 7. I need to find V. So I can use the easiest equation from the selection, V equals U plus AT. So U is going to be equal to 25, because that's what I figured out before in the first part of the question, plus AT, but plus A is minus 10 times by the time, which is 7. That is going to be equal to minus 45. So now we know that it's going to look like this. So we're going to go 60 meters across and minus 45 meters per second down. So that's 45, that's 60. I want the speed, which is just the magnitude. So therefore, the speed is equal to the square root of 60 squared plus 45 squared. That's equal to a very nice number of 75 meters per second. The reason we're getting nice numbers here is because we've taken the G value as 10 instead of 9.8. So yeah, how is this making sense? Is this making sense so far? Just checking the chat with honorary moderator Bryn. Grade lower this YouTube. I'm gonna get 40 on stats. Find it hard. Stats people tend to like mechanics more, so I don't blame you. Yeah, 49 out of 50. Nice. Nice marks I'm seeing. Yeah, mechanics, make sure you maximize the marks in mechanics, all right? What I recommend when you get your papers on the day, look through both of those papers. If there is a big chunky question which you know you can easily secure the marks for, maybe do that first, just so you're guaranteed most of the marks, all right? What I did was, I don't like stats like most of you guys. So I decided to do stats first, so I spent a bit more time because I'm better at mechanics than stats. So I knew I didn't need as much time with mechanics and I wouldn't be as stressed in those time conditions. So I started with stats. Question one put me off, but I just left it, finished the rest of stats, finished mechanics, then came back to question one in stats at the end and then got that. That's what I did. So yeah, do whatever you feel like. Mechanics pretty much carries most people, I'll be completely honest. So yeah, I feel the same way as you guys. Awesome. Now, we've done the fun part of this question. We've just got the last bit. I want everyone to put in the chat what they'll put for part C. One limitation of the model is that it ignores air resistance. State one other limitation. So notice the word other. You can also say air resistance that could affect the reliability of your answer. All right, I'm going to look at the chat now. More accurate measure for G. Exactly. You've taken G as 10. So use 9.8 or 1 meters per second. Dimensions of stones. Spin exactly is a nice option. Bison mass is good as well. Ignore spin. Yup, you don't want to ignore spin. What else? It's the dimensions of the stone you can take into account, right? G is also assumed to be constant, right? But it may not be constant as it changes through this. How tall is it? It's a 70-meter drop. It's pretty big drop, so G may not be constant there. You can also have my personal favorite. If you're throwing something off a cliff, you've got wind. It does not take into account anything to do with wind. I think we've covered all of the possible assumptions used in that. Does anyone have any questions about this projectiles question, question 4? I have videos going through how to do these. I made them themed in case you guys have noticed. I put a theme on each of my stats and mechanics videos each day to make them interesting. So I'm hoping you guys are enjoying my little videos that I've got going up. Let me know your thoughts and stuff. Tomorrow is the last day I'm posting videos before your exam. If there's anything you want to see, let me know. And tomorrow's live is going to be both stats and mechanics. We'll be doing a paper there. So make sure you join for that. Share with anyone who you think will benefit. If you want to ask me any questions now, advice and stuff to do, or anything you're unsure of, do let me know now. I'll be on for a few more minutes. What do you think A-star boundary will be? I reckon I'm currently on 166 to 170, thinking what I need. A-star boundary, you never know, honestly, because some people are saying they found paper too hard. Some people are saying they found it easy. But A-star boundary, look at the 2024 one. That one was pretty high. But the 2024 papers were generally easier than previous years. Don't bother with large data set and go through the book. Yeah, but large data set, if you check out my live yesterday when we did the large data set question, I said the main things you need to know. Any general advice for stats? All right, so my top tips for stats. Know your distributions and know how to use them. So make sure you are fully confident in the normal distribution because that question is going to be probably one of the bigger questions in the exam. It may be an easy big question or it may be a really difficult big question. So make sure you are fluent in normal distribution and binomial distribution. Make sure you understand how they work and their conditions, right? They may ask you what is the condition required for it. I got a video on that too. So what else for stats? Make sure you're very happy with Venn diagrams and probability trees, conditional probabilities and their formulas, because if you need to be able to apply that given that formula where this is the formula. The probability of A given B is the probability of A and B divided by the probability of B. You need to be able to apply this formula in more complex contexts. One of the questions I did yesterday on my live or two of them actually, did a very advanced version of that with like inequalities and all. So make sure you're happy with that. Box plots, histograms, cumulative frequency, that sort of stuff. Histogram could come up. It came up in 2023, so it may not, but it could come up in the 2024-5 paper. But yeah, that and large data set, don't sweat too much about it. Just know what the variables are, what they're measured in, and how to measure, what they're measured in. Just know the locations and where they are on the map of the UK and on the world, and know that Perth is in Australia, it's in the southern hemisphere, so the seasons are swished there and you should be good to go more or less. Yeah. Let me see any other questions. 245. Yep, they should be free marks compared to the other ones. Yep, that's disgusting. I'm doing a discrete question and it's not easy. Yeah, I'm gonna be honest. I hate discrete random variable questions. They are tricky. The video I posted, I think the first video I posted today did a question about gaining XP points and all. Um, Gaining XP points where it was a discrete random variable. You just have to kind of logic them through. Check out the recording from my live yesterday. We did 2 discrete random variable type questions, and you can see how we worked through those. I am doing this tomorrow as well. I'm going to be doing stats and mechanics tomorrow. So a full paper, 50-50 marks. So, yep, feel free to, I would appreciate if you came for that as well. Looking forward to seeing you there. Can you please repeat part B? Sure, part B for the projectiles question, I'm guessing, right? So, for part B, I need to find the speed of the stone just before it hits the ground at A. The word speed means it's a scalar, so I need to find the magnitude of both the vertical and the horizontal speed components, right? So, horizontally, I know that the speed is going to be 65 cos alpha. Why? Because it's launched at an angle there. This is the horizontal component, and it remains constant the entire time. There's no horizontal acceleration. Boom, 60 meters per second. Vertically, I'm going to use v equals u plus at because I want the final speed, right? And for my part A, I can see I've got all the other variables, so I can pick any equation I want. I pick the easiest one. So u is equal to negative 70, u is equal to 25 plus at, which is minus 10 times 7, that's what at is, I get minus 45. So 60 and minus 45 are my velocity components. I have to find the magnitude of that, so that's the square root of those two squared added, and you get 75. That's how you do part B. Remember, scalars, you have to do thing. Histogram was in 2024. Histogram was in 2024? I did 2024. I'm just trying to think, did I have a histogram question? I don't think I did. I hate histograms. I think question 1, question 2. I don't think question histogram was on 2024. You might be thinking maybe it was on the AS paper, but from memory, I don't think we got a histograms question. We got a Venn. Did we get a Venn diagram? Yeah, we got a Venn diagram question at the end from that unit. Am I done? Yep, I am done with mech now, but I'm going to post this live recording. Let's see, if it posts by tonight, by around midnight, I'll get it up. If not, it's going to be up first thing tomorrow morning, depending on when I wake up. I wake up early, so don't worry. No worries, Charles. Thanks for following along. Can you over a discrete distribution question from 2021? Let me just go check. Discrete distribution from 2021. That's 2021 question paper. I think it was the last question. This one. Do you want me to go through this question? Is this the one? Follow those guys. Really appreciate all the support. All right. Yep. It will be in the YouTube video. So this is, if you want to look, this is the question you're looking for. This is one of the last questions on that. Do you think we'll get you may get a ladder question because last year I think it was a thing leaning against, I'm just trying to think, what was it? It was something leaning against a rod sticking outwards, I think, and there was a moments on that. So you could get a ladders, you're most likely going to get that. It is coming up every year, we've seen. Thanks for following me. I'm glad you liked this, just a random. Glad it was helpful. I hope I made it engaging and didn't bore you guys with it. But yeah, that's how we do. That's the stats paper. I need to close off on the mechanics paper. So yeah, I've got my live prepared for tomorrow. We're going to be doing the 2022 papers. So stick around for that. And thank you for following on. Does anyone have any other questions or anything else they want to say before I sign off? Or are we all good? I hope that was good. Appreciate this. No worries, eh? Glad it was useful. Gonna close off on the projectiles question. Looking nice. Awesome. Best of luck with your revision. I'll be back tomorrow and maybe next year. Awesome. Thank you for all your help, Bryn. And appreciate all the gifts and support from everyone. And yeah, looking forward to seeing you guys tomorrow in my live. I want to have like a big live tomorrow, hopefully, try and get as many people. So yeah, share it as much as you can. I appreciate all the help. But yeah, I will see you all tomorrow where we will do stats and mechanics. No worries, guys. Take care. Feel free to DM if you have any questions. All right. No worries, Sakura. Bye bye. Thank you, man. Thank you, eh?